Hello everyone. Chapter 2, Reasoning and Proofs, Sections 2.4 and 2.5 combined. Algebraic reasoning and proving statements about segments and angles. Okay, example 1. Justify each step. We have to start somewhere. And we always start with information that has been given to us. So we're given this equation, and the reason that justifies that step is quite simple. It's given. What has happened when going from this equation to this equation? What's changed? Well, the 2x minus 5 is still here. The 13 is still here. What's new is we have a plus 5 on the left and a plus 5 on the right. What allows us to do that is the addition property. What has changed going from statement 2 to statement 3? Negative 5 plus 5, 0. 13 plus 5 is 8. So all we've done is combine like terms. Now the book is going to say simplify. I prefer combine like terms, CLT. I believe it is more descriptive. So that's the expectation. Going from step 3 to step 4, we've divided the left side and the right side by 2. Division property. And going from step 4 to step 5, we have done the actual dividing. We've reduced the 2 and the 2, the 18 and the 2 to get a 9, and we reduced. Okay, example 2. Again, justify each step. Start with the given equation. Going from statement 1 to statement 2, we have multiplied the left side and the right side by 5. On the right side, the 5's cancel. It stays on the left-hand side. And we multiply the left side and the right side by 2. The 2's cancel, and we get a 2 over here. Or you can think of it as multiplying the left side and the right side both by 10. If you multiply the left side by 10, the 2 cancels with the 10 or reduces with the 10, you get a 5. The 5 reduces with the 10, and you're left with a 2. So multiplication property. I'm going to start using abbreviations. Multiplication property. Going from statement 2 to statement 3, distributive property. Going from statement 3 to statement 4, subtract the 2x from both sides, subtraction property. Going from statement 4 to statement 5, added 10 to both sides, addition property. And going from statement 5 to statement 6, addition property. And we're on to example 3. Again, solve and justify each step. So there's 2 ways to solve this problem. One way is start off by dividing both sides by 2, which is what I'm going to do. This is a little different from the answer key. Oh, this is given. In the answer key, I distributed first, distributive property, just to show you that that's a different way of doing it. But I actually like x plus 1 equals negative 2, division property. Dividing both sides by 2. X equals negative 3, subtraction property. And I do it in one fewer step. Okay. Example 4. Use the formula P times quantity 1 minus RT equals A to find the value A of an investment, where P is the original principal invested, R is the rate of simple interest as a decimal, and T is the time in years the money is invested. Solve the formula for T. How many years will it take until the principal of $250 grows to a value of $285 when the simple interest rate is 2%? So the first thing we need to do is take this equation and solve it for T. I think when I did this on the answer key, I distributed the P and then solved for T. I'm actually going to do this by dividing by P first. Doing it this way actually does make it a little bit trickier at the end. I have to get a common denominator, but that's fine. Subtract 1. And I probably should get the common denominator now, but I'm not going to. I'm going to do it at the end. Divide by R. And get my common denominator. A minus P over PR. And there's my formula solved for T. I'm now going to use this formula to answer the rest of the question, which is to find out how many years it will take for the principal of $250 to grow to $285. So T equals A minus P over PR. Substitute the A is the amount is $285. The principal, the amount that we start off with, $250, over principal, $250, times the interest rate, simple interest rate, 0.02%. Is written as 0.02. The numerator becomes 35. The denominator, 2% of 250 is 5. And this simplifies to a nice time equals 7 years. So in 7 years, your investment of $250 will be $285. That's example 4. Let's take a look at example 5. You bounce a pool ball off the wall of a pool table as shown. Determine whether the measure of angle RTP is equal to the measure of angle STQ. So we want to know, essentially, is angle 1 equal to angle 3? It is. Let's do it. What you might not see in the diagram, this arc here indicates that angle RTQ is congruent to the same measure of angle PTS, because that PTS also has an arc here. So it's a little hard to see it. Let's see if I can get a better focus here. About the same. So that's given information. It's given information in the diagram. Let me write that down. Measure of angle RTQ is equal to the measure of angle STP, and that's given information. Okay. What else do we know from this diagram looking here? Well, what do we know about angle RTQ? We know that that angle is comprised of angles 1 and angle 2. We know that by the angle addition postulate. In other words, measure of angle RTQ is equal to the measure of angle 1 plus the measure of angle 2. That's the angle addition postulate. Like I said, I'm using abbreviations. This video is going to be long already. So, what else do we know? We know angle STP is comprised of angle 2 and angle 3. So, measure of angle STP equals the measure of angle 2 plus the measure of angle 3. Again, angle addition postulate, or AAP. Suppose I could abbreviate. Okay. Well, how does that help us? Well, we know that RTQ is equal to STP from statement 1. So combining statements 2 and 3 with statement 1, I can do measure of angle 1 plus the measure of angle 2 equals measure of angle 2 plus the measure of angle 3. Substitution. Property. I do want you to write out the word substitution because I don't want it to be confused with subtraction by accident, which comes up next because we have a measure of angle 2 and the measure of angle 2 on both sides of the equal sign. If I subtract the measure of angle 2 from both sides, I am left with measure of angle 1 equals the measure of angle 3, which is what we were trying to prove. Subtraction property. Again, using my abbreviations. And I can move on to example 6. There are 2 exits from Theater 10 at the local cinema. The cinema manager wants to put a trash can along the wall, the same distance from each of the 2 exits. Create a diagram to model this problem. So show the distance from the trash can to the left exit is half the distance between the 2 exits. Okay, so I'm going to turn the paper here. Here's my wall. Oh, that is so bad. Here's my wall. These points here are the 2 exits, and the trash can is going to go halfway between them. Okay, breaking the distance between the 2 exits into congruent segments. Okay, let's label these A, B, and C like I did in the answer key. And we're given that the cinema manager wants to put the trash cans the same distance from each of the 2 exits. So the trash can B here, so the distance from A to B has to be the same as the distance from B to C, and that's given information. Given to us by the cinema manager who wants the trash can there. Okay. Well, what else do we know? We know that if we add these 2 small segments together, we get the bigger segment. So the measure of segment AB plus the measure of segment BC is equal to the measure of segment AC. Segment addition postulate. Okay, if I replace, I have a choice here. I'm going to replace the BC with something that it's equal to. Well, BC is equal to AB. So I'm going to write AB plus AB equals AC. That's just substitution. Substitution property. Okay. AB plus AB is 2AB. Is equal to AC. That's combining like terms. Again, the book will say simplify. Combining like terms is more descriptive. Divide both sides by 2. AB is equal to 1/2 AC, division property, and we have just proven that the trash can is half the distance between the two exits. Half the distance between the two exits, A to C. That's example 6. Example 7. Supply any missing statements and or reasons. We're told, we're given that the measure of segment FL is equal to the measure of segment AT, which I've already marked in the diagram for you. I don't usually do that, but I have this time that I've marked segment FL can go into segment AT. Our goal is to prove that the measure of segment FA is equal to the measure of segment LT. So from F to A is the same as from L to T. That's our goal. All right, so statement number 1, we're told the reason is given, not a surprise. So what is our statement? FL, measure of segment FL, equals the measure of segment AT. That's the given information, it's the given statement. All right, if we look at statement 2, the measure of segment LA is equal to the measure of segment LA. How do we know that? Even without a diagram, we're going to know that the reason for that is the reflexive property. Okay. FL plus LA equals AT plus LA. How do we know that? Well, what's changed here? What's going on here? This seems like if we take statement 1 and we add to the left LA, and if we take statement 1 and we add to the right LA, we're adding equal things to both sides of the statement 1, we get a new statement. So what allows us to do that? Addition property. Okay. FL plus LA equals FA, and LA plus AT equals LT. Let's look at the diagram. FL plus LA equals FA, and LA plus AT equals LT. What allows us to make those two statements? Well, I've combined them into one statement because they have the same reason, and that's the segment addition postulate. Okay, I have a hint here, it's substitution property, but I have another hint that doesn't usually happen when we're doing proofs and quizzes and tests, and that this is the last statement. And the last statement in the proof has to be this, has to be what we're trying to prove. So even before I started this proof, I knew this was going to be the last statement. And if this wasn't a fill-in-the-blank proof, I wouldn't have known what the last reason was, but because it's a fill-in-the-blank proof and this was given to me, I knew the last reason was substitution property. This has to be my last statement. So if we write out FA equals LT, now I'll tell you why FA equals LT. So if this wasn't a fill-in-the-blank proof, and if I didn't tell you that there were 5 statements, you wouldn't have known when this was going to occur. But we know now because FA is equal to FL plus LA. FL plus LA is here. So if I replace FL plus LA with FA, I get an FA here on the left side. LA plus AT is equal to LT. AT plus LA is equal to LT. So if I replace the AT plus LA with the LT, I get an LT on the right-hand side, and I get this statement FA equals LT by the substitution property. Okay, example 8. Error analysis. The steps below show that 1 is equal to 2. Clearly that's not true, so we have to figure out what the mistake is. What's the error in the proof? So let's go through this proof very simply and slowly. So we're given that A equals B, 6 equals 6, 7 equals 7, 100 equals 100. So if A is 100, B is also 100. They're equal. Okay, so that's what's given to us. what have we done to go from statement 1 to statement 2? Well, it looks like I multiplied the left side by b, and I multiplied the right side by b. B times b is b squared. A times b is ab. Multiplication property. That seems okay so far. What have I done to go from statement 2 to statement 3? Well, again, what's changed? Let's look to see what's different. We have the AB still here. It looks like we've subtracted an A squared from the left side. We have the B squared still here, and it looks like we've subtracted the A squared again. So it looks like we've subtracted equal things from the left and the right. Subtraction property. That seems okay. If we take a look at the left side going from statement 3 to statement 4, if we remember our algebra from last year, let's take a look at what's changed. Going from AB minus A squared to A quantity B minus A, what's changed? Well, it looks to me like we have undistributed the A. Technical term is factoring, but undistributing is more descriptive. We've taken an A that was common in these two terms out. Okay? If we look at the right-hand side, b squared minus a squared. This is a difference of two squares, something that you learned about last year. Difference of two squares factors into a b plus a, b minus a. That is distributing, or undistributing in this case. So the reason that you're allowed to do that is the distributive property. And you might think that this is where our error is, but algebraically speaking, we are spot on. This is exactly where we would be if we went from statement 3 to a statement 4. Statement 4 to statement 5. Well, if we notice what's changed on the left-hand side, we no longer have a b minus a, we just have an a. We no longer have a b minus a on the right-hand side, we just have a b plus a. What's happened? We didn't subtract b minus a from both sides. We divided the left-hand side by b minus a and divided the right-hand side by b minus a. Division property. That seems okay. So when we go from statement, oh, I've lost track of what number we're on. It's the statement 5 to statement 6. It looks like I've replaced this b with an a. Can I do that? Sure. A is equal to b. That was given to us right in the very beginning of the problem. Instead of writing b, we can replace it with a. Technical term for replacing is substitution. Substitution property. So we now have a equals a plus a. Okay? Seems legit. A plus a is 2a. Combining like terms. Divide both sides by a. A divided by a is 1. 2a divided by a is 2. Division property. Seems like 1 equals 2. But there is a mistake in here that we have to figure out what it is. Okay? And the mistake occurs right here when we go from statement 4 to statement 5. And you might be thinking, well, what's wrong with that? We did division property, right? Division property going from statement 4 to statement 5. We divided by b minus a. Divided by b minus a, we get this. That's a problem. What's the problem? Well, hopefully when you were writing out your properties and when you wrote the division property, you included the fact that you can never divide by 0. Okay. I did. I included that in my property. Can't divide by 0. I didn't divide by 0 here, but we did. Even though it doesn't look like it, we did. B minus a is 0. Why is b minus a 0? Well, a and b are the same number. Remember I said if a is 100, b is 100? 100 minus 100 is 0. This is equal to 0, no matter what the value of a and b is. This is 0, no matter what the values of a and b are. Division by 0 is not allowed. In fact, if you do allow it, weird things start happening, like 1 equals 2. Clearly 1 does not equal 2, so we've made a mistake. And that mistake was dividing by 0 right here. Alright. Example 9. Supply any missing statements and or reasons. In this case, they're all reasons. So they're all reasons that we're supplying in example 9. Simple reason for statement 1 is that it's given. That was an easy one. Measure of angle 1 plus the measure of angle 2. It looks like I'm adding angle 2 to the left-hand side of this first statement. And it looks like I'm adding angle 4 to the right-hand side of this first statement. Can I do that? Yes, because angles 2 and 4 are equal to each other. So I'm adding equal things to the left and to the right-hand side of an equation. That is the addition property. We are allowed to do that. The measure of angle 1 plus the measure of angle 2 equals the measure of angle ABC. Angle 1 plus angle 2 equals angle ABC. Looks legit to me. Angle 3 plus angle 4 equals angle DEF. Angle 3 plus angle 4 equals angle DEF. That is the angle addition postulate. AAP. What is happening going from statement 2 and 3 to statement 4? Well, measure of angle 1 plus measure of angle 2 can be replaced with measure of angle A plus ABC, and the measure of angle 3 plus measure of angle 4 can be replaced with measure of angle DEF. And we don't say replacing, the official term we use is substitution property. That was example 9. Example 10. Again, supply any missing statements or reasons in this case. They're all reasons that we're supplying. Reason 1, given. Reason 2, well, what's happened? If we look at ray BC bisects angle ABD. Even though it doesn't look like it in the diagram, and that's irrelevant, the fact that BC is bisecting angle ABD means that this angle and this angle have to have the same measure. That is the definition of an angle bisector. Okay. Measure of angle ABC in the diagram is equal to 6n plus 1. Measure of angle CBD is equal to 4n plus 19. What allowed me to do that? Substitution property. Okay. Going from statement 3 to statement 4, I have subtracted 1 from both sides, and I've subtracted a 4n from both sides, leaving me with a 2n equals 18. Subtraction property. And going from statement 4 to statement 5, I've divided both sides by 2. Division property. And I have proven that n equals 9. I'm going to take a second now to introduce you to an abbreviation that we traditionally write at the end of all proofs, QED. It's Latin. It's the 3 letters of the Latin words quod erat demonstratum. Loosely translated, it means proved or finished. That which I wanted to demonstrate has been demonstrated, or that which I wanted to show has been shown. Again, essentially it means finished. I have proven what I wanted to prove. And it's traditional for mathematicians to write QED at the end of all proofs. It dates back to when Latin was the official language for math and science. That changed to French, and now the official language is English. But QED has stuck. So that was example 10. Example 11. what can you conclude from the given information? So if we are given that AE is equal to DE, and we're given that CE is equal to BE, what can we conclude? Well, what can you tell me about AE and EC? Well, if I add them together, I get AC. What can you tell me about DE and EB? If I add them together, I get DB, segment addition postulate. Well, I'm adding equal pieces. Therefore, I can conclude segment AC has the same measure as segment BD. Okay, part B. I'm going to erase the information from part A and start new. Segment AC bisects segment DB. So AC is bisecting DB. Okay. DB is bisecting AC, but I'm going to hold off marking that off because I'm going to mark this up first. CE has the same measure as BE. BE has one tick mark, so that means CE has to have one tick mark. Now let's go back to this one. DB, segment DB, is bisecting segment AC right here. So it's cutting this segment into two congruent segments. One tick mark, one tick mark. What can I conclude? I can conclude that AE is equal to CE is equal to BE, which is equal to DE. All four of these segments are congruent. In fact, I can throw in two more because I can add AE and EC to get AC, and I can add DE to BE and get DB. Just like in part A, AC is equal to BD. And that's example 11, part B. Example 12, write a two-column proof. We're given that angle 1 is supplementary to angle 3, and we're given that angle 2 is supplementary to angle 3. And our goal is to prove that angle 1 is congruent to angle 2. So let's go through this one. And we'll start off by writing statement 1. Just to rewrite the given information, angle 1 is supplementary. Let's just do I'm just going to do one of the given statements in the first statement. So angle 1 is supplementary to angle 3, given. What does that mean? What does that tell us about angles 1 and 3? If angle 1 is supplementary to angle 3, what does that mean? Well, it means, statement 2, that the measure of angle 1 plus the measure of angle 3 is equal to 180 degrees. How do I know that? I know that because I know what the definition of supplementary angles is. Statement 3. Angle 2 is supplementary to angle 3, given. Okay, what does that mean? What does it mean for angle 2 to be supplementary to angle 3? It means the measure of angle 2 plus the measure of angle 3 equals 180 degrees. Again, because I know what the definition of supplementary angles is. Okay, if we take a look at statements 2 and 3, both statements are equal to 180 degrees. So since they're both equal to 180, they have to be equal to each other. Or another way of thinking of it, instead of writing 180 degrees here, I can write the measure of angle 2 plus the measure of angle 3 by substitution. That's probably the best way of thinking of it. Statement 5 is going to be the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. Substitution property. Okay. Statement 6. I have a measure of angle 3 on both sides. If I subtract the measure of angle 3 from both sides, I get the measure of angle 1 equals the measure of angle 2. Subtraction property. And you might be thinking, we're done. Write QED. We are almost done. This is almost what we have written. Well, I said earlier in the video, this will always be the last statement in the proof. And this isn't what we have written just yet. We're close. So statement 7. Angle 1 congruent to angle 2. How do I know angle 1 is congruent to angle 2? Well, I know the measure of angle 1 is equal to the measure of angle 2. And that is the definition of congruent angles. Now I can write QED. All right, example 13. Name the property that the statement illustrates. Angle A is congruent to angle A. This is a reflexive property of congruence. All right. Part B. If the if segment PQ is congruent to segment JG, and segment JG is congruent to segment XY, then segment PQ is congruent to segment XY. This is the transitive property of congruence. Okay. Example 14. Write a 2-column proof. Write a 2-column proof for the reflexive property of congruence. So we have this angle A. We're given angle A. Basically, what does that mean? That means that angle A exists. We're given that angle A exists. Our goal is to prove that angle A is congruent to angle A, the reflexive property of congruence. We have at our disposal the reflexive property of equality. So, if angle A exists, then the measure of angle A has to be equal to the measure of angle A. And that is the reflexive property, this time of equality. Okay. If two angles are equal, then they are congruent. The measures of two angles are equal, and the angles are congruent. That's the definition of congruent angles. And we have proven, QED, the reflexive property of congruence. All right, write a 2-column proof. Part A. Let's see. RP is equal to TQ. PS is equal to QS. Notice 1 tick mark, 1 tick mark, 2 tick marks, 2 tick marks. Our goal is to prove that that RS is equal to TS. So let's go through this. Statement 1, RP has the same measure as TQ. Do I combine these? Yeah, in one statement. And PS is equal to QS. Given. Statement 2. What do I know about RP and PS? Well, if I combine them, RP measure of segment RP plus measure of segment PS is equal to measure of segment RS and measure of segment TQ plus measure of segment QS is equal to the measure of segment TS, segment addition postulate. Statement 3. Statement 3 is if we take statement 1 and we add to the left-hand side PS, and if we add to the right-hand side QS, I'm adding equal things to the equation, to both sides of the equation. So RP P plus PS, adding the PS to the left-hand side here, equals TQ plus QS, adding the QS to the right-hand side here. That's the addition property. And what you notice is if you've looked at the answer key, I flip-flopped statements 2 and 3, and that doesn't matter because statement 3 does not come from statement 2 does not come from statement 3, so they're interchangeable. The order of statements 2 and 3 really doesn't matter. I think I did on the answer key, I put statement 3 as statement 2 because it came from directly from statement 1. But the truth is it really doesn't matter. In flow proof, it would be shown that this came from this by arrows, and you would see no arrows connecting statements 2 and 3 at all, because they're not. You would see arrows coming from statements 2 and 3 combining to give us this statement 4, because we're going to replace the RP plus PS with RS, and the TQ plus QS with TS. And we get RS is equal to TS by substitution. Substitution property, QED. Let's take a look at part B. So part B, I'm going to get rid of the tick marks from part A. Reuse the diagram. Measure of angle SRT. SRT is equal to the measure of angle STR. Those two angles are equal. And the measure of angle 3 is equal to the measure of angle 4. Those two angles are equal. Our goal is to show that the measure of angle 1 is equal to the measure of angle 2. Very similar to the proof that we just did. Let's go through it. Statement 1. Measure of angle SRT equals the measure of angle STR, given. Statement 2. If we look at the diagram, what can you tell me about angle SRT? Well, it's a combination of angles 1 and 3. And what can you tell me about angle STR? It's a combination of angles 2 and 4. So, measure angle 1 plus the measure of angle 3 equals the measure of angle SRT, and the measure of angle 2 plus the measure of angle 4 equals the measure of angle STR. How do I know that? B, angle addition postulate. It tells me that those add up to be the bigger ones. All right, statement 3. Instead of writing S to measure of angle STR here, I'm going to write the measure of angle 1 plus the measure of angle 3. And instead of writing the measure of angle STR here, I'm going to write the measure of angle 2 plus the measure of angle 4. Measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 4. And that's the substitution property. Okay. I still haven't used my second given. Measure of angle 3 equals the measure of angle 4. Measure of angle 3 equals the measure of angle 4. Given. Well, 3 and 4 are equal. We're allowed to subtract equal things from both sides. If I subtract angles 3 and 4 from the left and the right hand sides of this equation, I am left with measure of angle 1 equals the measure of angle 2, which is what I was trying to prove. Subtraction property. Given. Q, E, D. 15. Now for example 16, I apologize. Example 16 got cut off. The diagram got cut off, so I had to redraw it. Write a two-column proof. We're given that the ray MP bisects angle LMN. So ray MP is bisecting angle LMN. What does that mean? It means that these two angles are congruent to each other. And our goal is to prove that 2 times the measure of angle LMP is equal to the measure of angle LMN. All right, so given MP, ray MP bisects angle LMN. That's given information. What do we know? Since that information is given to us, we know that angle LMP is congruent to angle NMP. How do we know that? We know the definition of an angle bisector. Okay, what else do we know? Well, we know if 2 angles are congruent, then their measures are the same. Measure of angle LMP is equal to the measure of angle NMP. Definition of congruent angles. What else do we know? Well, we know if we add this angle to this angle, we get the big angle. So measure of angle LMP plus the measure of angle NMP is equal to the measure of angle LMN. Measure of angle LMP plus the measure of angle NMP equals the measure of angle LMN. Angle addition postulate. These are angles, not segments. AAP. Statement 5. Instead of writing measure of angle LMP, I'm going to replace that. Instead of, I have a choice. I can replace the, no, I don't have a choice because I want 2 times the measure of angle LMP. So I want to keep this one. I want to replace this one. The measure of angle NMP is equal to the measure of angle LMP. So I'm going to replace this with this. So the measure of angle LMP plus measure of angle LMP equals the measure of angle LMN. Substitution property. And 6. Measure of angle LMP plus the measure of angle LMP is 2 times the measure of angle LMP equals measure of angle LMN, and that is combined like terms. Q, E, D. Quad arit demonstratum. That which I want to demonstrate has been demonstrated. Example 17. Write a 2-column proof. We're given that ray AC bisects angle DAB. So this angle is equal to this angle. Ray CA bisects angle BCD. So this angle is equal in measure to this angle. We're told that angle 1 is equal to angle 3. So I have 1 tick mark here and 2 tick marks here. I could erase, and it's going to be easier to make this 2 tick marks and this 2 tick marks. So we have 2 tick marks, 2 tick marks, 2 tick marks, 2 tick marks. Our goal is to prove that angle DAB is equal to angle DCB. So let's get to it. Statement 1 is to rewrite all the given information. Now, I'm going to take a shortcut. You are not allowed to take this shortcut, but I have a college degree and I can do this. You can't. When you get a college degree, you can rewrite the given with just squigglies. This video is already long enough, so I'm going to put some squigglies in there. All right. If AC bisects DAB, then angle 1 is equal to angle 2. Measure of angle 1 equals measure of angle 2. And ray CA bisects angle BCD, so angle 3 is equal to angle 4. Measure of angle 3 equals the measure of angle 4. Oops, reason 2 for the given. Reason 1. And this is definition of angle bisector. Oops. That's better. So, statement 3. If I add angle 1 and angle 2, I get angle DAB. If I add angles 3 and 4, I get angle DCB. So the measure of angle 1 plus the measure of angle 2 equals the measure of angle DAB, and measure of angle 3 plus the measure of angle 4 equals the measure of angle DCB. Reason 3, angle, addition, postulate AAP. Statement 4. I can replace angle 2 here. I have a choice. I'm going to replace this angle 2 here with this angle 1, because angle 2 is equal to angle 1. And I'm going to replace this angle 4 with this angle 3. That way I'm going to have a statement that has angle 1 in it and a statement that has angles 3, which this will help me with up here. So measure of angle 1 plus the measure of angle 1 equals the measure of angle DAB, and the measure of angle 3 plus the measure of angle 3 equals the measure of angle DCB. Substitution property. Now, statement 5. Angle 1 plus angle 1 is 2 times the measure of angle 1 equals the measure of angle DAB, and 2 times the measure of angle 3 equals the measure of angle DCB. Reason 5 is CLT, combined like terms. 6, statement 6. Instead of writing angle 3 here, I can substitute in angle 1, because they're equal. So 2 times the measure of angle 1 equals the measure of angle DAB. 2 times the measure of angle 1 equals the measure of angle DCB. Again, substitution property. And final statement. Instead of writing 2 times the measure of angle 2, I'm going to replace that with the measure of angle DAB. Measure of angle DAB equals the measure of angle DCB. Reason 7 is again substitution property. QED. And that is the end of the 2 sections 4 and 5. Thank you very much.